Okay, hopefully the last video, hopefully the next problem is not as long as that one. And I know that, and I somewhat apologize for doing that problem, but not completely. Like I said, got to practice hard stuff. That's the only way you get good at things. Okay, so differentiate the following. So the previous problem, we started with the chain rule because we were able to explain it entirely as inside, outside. This one, it's not a chain rule to start. It's a quotient rule to start because it's numerator over denominator. Now please do remember, this is the same thing as this, sine of 3x to the fourth over x squared plus 4 to the fifth. But we're going to start with a quotient rule. So, plain denominator. Derivative of the numerator minus plain numerator derivative of the denominator. All over the plain denominator squared. Plain denominator, derivative numerator, plain numerator, derivative denominator, plain denominator squared. Okay, so we start with quotient rule. And you don't have to write that step down. So moving on now, plain denominator, so I don't do anything. Derivative of the numerator. The 4 is on the outside, so I start with that 4. Multiply by the exponent, decrease the exponent by 1, times the derivative of the inside. So derivative outside, derivative inside. And I'm going to drop down because I'm running out of room, so we'll put minus, drop down. Plain numerator, so leave it alone. Derivative of the inside, derivative of the denominator, excuse me. Start on the outside. Multiply by that exponent. Leave everything else alone. Then times the derivative of the inside. So derivative outside, derivative inside. Now we had some chain rules here. Chain, chain. And then all over my denominator, exponents to exponents, I multiply. Okay, let's keep whacking away at it. So I'm going to move that 4 to the front. So I got x squared plus 4 to the fifth, sine cubed 3x. Then I come to that last derivative, and as we've talked about many times, the effect of that 3 in the sine 3x from the chain rule is to multiply by it. So it's going to be 3. Derivative sine is cosine. The angle stays the same. Up to the minus sign, it's going to move that 5 up to the front. So then I have sine to the fourth, 3x, then x squared plus 4 to the fourth, and then finally that derivative on the end, 2x, all over x squared plus 4 to the 10th, and there's my unsimplified derivative. And we're going to simplify. But there all my calculus is done. And again, like I said, if I gave a problem like this, most of the points come from the calculus. You should get a C by being able to do all the calculus. Okay, simplifying. Here's 1 time where you are going to get to cancel. Note, all terms contain x squared plus 4 to the 5th, x squared plus 4 to the 4th, x squared plus 4 to the 10th. They all contain x squared plus 4 to the 4th. So I can cancel from all terms x squared plus 4 to the 4th. Here's one of the rare times where I'm going to get to cancel when I'm doing when I start with a quotient rule. So doing that, canceling x squared plus 4 to the 4th from everybody. So that one is completely gone. I had 4, I'm canceling or dividing out 4. I had 10 of the factors, canceling or dividing out 4 of them, so it'll be 6 left behind. Same idea here. I had 5 of those factors. I'm canceling or dividing out 4, so there'll be 1 left behind. So I'm going to come up with 4 times 3 is 12, then x squared plus 4, sine cubed 3x, cosine 3x, minus 5 times 2 is 10, so 10x, sine to the 4th 3x, all over x squared plus 4 to the 6th. Then if you wanted to, and I'm tired of this problem so I don't, if you wanted to, you could distribute out all this here. It wouldn't make the problem any prettier, so I'm not going to bother. It wouldn't give you any new like terms or anything, but that's the only other thing you could do here is you could do some distributing right in here, and I don't care about it. So there's that answer. And again, emphasis that here was one time we actually could cancel within that fraction, but notice we canceled the same thing from all the terms. That's when you can cancel in a fraction. Okay, last problem from this section. Find the equation of the tangent line to the given curve find the equation of the tangent line to the given curve at x equal 1/3 natural log of 20. Okay, so same tangent line problems as before. We need a slope and we need a point. Need a point at x equal 1/3 natural log of 20. And there's going to be some algebra review along with this one. So if x equals 1/3 natural log of 20, y is going to be f of 1/3 natural log of 20, which will then be e raised to the 3 times 1/3 natural log of 20 all over 4. Just plug it in there. We're going to simplify that, dude. So the 3 and the 1/3 obviously cancel. And we get e to the natural log of 20 over 4. We'll talk much more about this in the future when we get more to logarithms. But algebra you were supposed to have experienced too in the past was this, that e raised to the natural log of x is x, and the natural log of e to the x is x. That the natural log and the natural exponentials are inverses of each other. And so when I compose them, put one inside of the other, because they're inverses, they quote-unquote cancel. I don't like that word cancel, but students understand what it means. They cancel, leaving me just the argument x here. So e raised to the natural log of x is x, and natural log of e to the x is x, because the natural log function and the natural exponential function are inverses. So in this case here, e raised to the natural log of 20 is 20, and so then I have 20 divided by 4, and so my point is 1/3 natural log of 20, 5. We need the slope. at x equal 1/3 natural log of 20. Well, as always, my slope is my derivative, so it's going to be f prime of 1/3 natural log of 20. So I got to find f prime, plug in x equal 1/3 natural log of 20. So just recalling up here, f of x is e to the 3x over 4. We're going to make our lives as easy as they can be. That's 1/4 e to the 3x. I have so many people that will do a quotient rule on this, which isn't wrong, but it's so much harder than it needs to be. Just bring that 4 out as a 1/4. And so then my derivative, the coefficient just stays, repeats, derivative of the exponent. Repeats, derivative, exponent. And so I've got 3/4 e to the 3x is my derivative. And so then my slope, which was going to be my derivative evaluated at 1/3 natural log of 20, becomes 3/4 e raised to the 3 times 1/3 natural log of 20. Simplifying. And so that's 3/4 e to the natural log of 20. But then the remainder is still up there. E raised to the natural log of x is x. The natural log and the natural exponential are inverses. So when I have them both, they quote-unquote cancel. In this case, I'm just going to get 20. And what that gives me, 15. So there are my calculations. We're going to end the video and pick up with the answer and then checking that answer, because this is one of the things I am going to be able to check. But there's my slope, 15. Ending this video.